Hello friends, welcome back to our channel. I hope you all are well. So today I am back with another video to continue our UCAT test preparation. So as you guys know, we have completed our verbal reasoning practice test questions and all types of decision making practice test questions. And here we have this last type of decision making practice test questions. So we're gonna continue it from question number 17. But before we start, I want to tell you about our videos that if you are new to this channel, you can watch our last videos on tour tutorial, question bank tutorials and practice test questions. So you can continue it from that with this video very easily. Okay, so without any further delay, let's start our video. First question we have is that a group of friends plan to go on a picnic. There is 40% chance of bad weather on Saturday and 60% chance of good weather on Sunday. There is 30% chance the temperature will be extreme on Saturday and 50% chance that the temperature will be moderate on Sunday. Considering only the chance of good weather and the likelihood of the temperature being moderate, is Saturday the better choice for going on a picnic? Option A, yes, there is a 20% higher chance of moderate temperature on Saturday. Option B, yes, there is a 20% higher chance of good weather on Saturday. Option C, no, there is a lower chance of extreme temperature on Sunday. Option D, no, there is a lower chance of bad weather on Sunday. So here we have a correct response is option A. It is correct because the chance of moderate temperature is a 70% on Saturday. That is 30% chance of extreme temperature is equivalent to 70% chance of moderate temperature. The chance of moderate temperature is 50% on Sunday. So there is a 70% minus 50% equals 20% higher chance of moderate temperature on Saturday. Option B is incorrect because the chance of good weather is the same for both days. That is 40% chance of bad weather is equivalent to 60% chance of good weather. So C is incorrect because there is a higher chance of extreme temperature on Sunday. Option D is incorrect because the chance of bad weather is the same on both days. So here we have a correct option is option A, which says yes, there is a 20% higher chance of moderate temperature on Saturday. Next question we have that there are two routes to climb a mountain peak. There is a 60% chance of traffic congestion in route A. Route B has a 60% likelihood of remaining congestion free. The success rate of reaching the peak is 80% for route A. The failure rate for route B is 20%. So option A we have that yes, individuals taking route A have a 60% higher chance of reaching the peak. Option B, yes, there is a 40% higher chance of no traffic congestion in route A. Option C, we have that no, individuals taking route A have a higher chance of failure. Option D, we have that no, there is a higher chance of traffic congestion in route A. So let's see which one is the correct option and which one is the not. So here we have correct option is option D. A is incorrect because individuals on route A have the same chance of reaching the peak as those on route B. A success rate of 80% is equivalent to a failure rate of 20%. Option B is incorrect because there is a 40% chance of no traffic congestion in route A and a 60% chance of no traffic congestion in route B. So there is a 20% lower chance of no traffic. So here we have option C, which is incorrect because whilst both routes have the same success route, route A has a 60% chance of traffic congestion compared to 40% in route B. So that's why we have a option D as the correct option, which says no, there is a higher chance of traffic congestion in route A. At a carnival, Jason has sufficient money to visit either stall A or stall B. The probability of winning a game at stall A is 1 by 3, and the probability of losing a game at stall B is 2 by 3. So the probability of winning a toy of Jason's choice at stall A is 0.89. The probability of not winning a toy of Jason's choice at stall B is 0.95. So considering only the likelihood of winning a game and getting a toy of Jason's choice, is stall B the better stall choice? Option A, yes, there is a 66% higher chance of winning a toy of Jason's choice at stall B. Option B, yes, there is a 33.33% higher chance of winning a game at stall B. Option C, no, there is less chance of winning a toy of Jason's choice at stall B. Option D, no, there is a less chance of winning a game at stall B. So now let's see which one is the correct option and why. So here we have a correct option is option C. A is incorrect because there is a 1 minus 0.95 equals 0.05 chance of winning a toy of Jason's choice at stall B. There is a 0.89 minus 0.05 equals 0.84 or 84% lower chance of winning a toy of choice than the chance at stall A. Option B and D are incorrect because there is an equal chance of winning a game at stall A and stall B. That is 1 by 3 probability of winning is equal to is equivalent to 2 by 3 probability of losing. And C is correct because there is a chance of Jason winning a toy of his choice is 0.89 at stall A and 0.05 at stall B. So there is a less chance of winning a toy of Jason's choice at stall B. So that's why we can say that option C is the correct option, which is that no, there is a less chance of winning a toy of Jason's choice at stall B. Next question we have is question number 20, which says, in a population there are more blue-eyed people than not and more clever people than not. These traits are independent. Is the probability that one person chosen at random has blue eyes and is clever greater than the probability of two people chosen at random being clever? So here we have option A, that yes, providing there are more blue eye than clever people in the population. And we have option B, which says yes, as with two people the probabilities are multiplied together, making the answer smaller. Option C, no, as we don't know the numbers of each trait in the population. Then we have option D, that no, as we don't know whether clever people are more likely to be blue-eyed. So here we have these four options. So let's see which one is the correct one and which one are the incorrect options. First we have correct option, which is option A. It is correct because if B is the probability of a person having blue eyes and C is the probability of a person being clever, then the probability that they are both clever and have blue eyes is C multiplied by B. So the probability that two people are clever is C multiplied by C. And if there are two people with blue eyes, then B would be greater, which means the probability of C multiplied B would be greater than C multiplied by C. Then we have option B, which is incorrect because the information states that both traits are independent. Then we have option C, which is incorrect because we do not need to know the numbers. Option D is incorrect because although it is true, it does not directly answer the question. So here we have these options are as the incorrect options, and option option A is the correct option, which says yes, providing there are more blue eye than clever people in the population. Next we have question number 21, which says the probability of Sam, Jack and Eliza processing a loan application is 0.3, 0.6, 0.1 respectively. The number of mistakes made by them per 100 application is 33, 16 and 22 respectively. So if 1000 applications are processed in a month, does Jack make the most mistakes? So option A, that yes, Jack makes the most mistakes because he does the most work. Option B, yes, Jack makes the most mistakes because his accuracy is low. Then we have option C, that no, Sam makes the most mistakes. And option D, no, Eliza makes the most mistakes. So now we have to know in these options that is the Jack who makes more mistakes. So let's see which one is the correct option. Is it true or not? So here we have a correct option is C, So first let's see why the other options are incorrect. A is incorrect because Sam makes the most mistakes, and B is incorrect because Jack has the highest accuracy, that is 16 mistakes in 100 applications compared to 33 and 22 mistakes. Then we have option C, which is correct because of the 1000 loan applications, Sam will process 300. Jack will process 600 and Eliza will process 100. So as Sam makes 33 mistakes per 100 applications, he will make a total of 33 multiplied by 3 equals 99 mistakes. And Jack makes 16 mistakes per 100 applications. So we'll make a total of 16 multiplied by 6 equals 96 mistakes. And Eliza makes 22 mistakes as she has 100 applications to process. Therefore, Sam makes the most mistakes with a total of 99. Then we have option D, which is incorrect because Sam makes the most mistakes. So we have the correct option is option C, that no, Sam makes the most mistake. So the above statement which asked that is Jack is the one who makes most mistake is the false one. Next we have that Jim can choose either science or mathematics. There are 4 possible grades for these subjects: A, B, C and D. And the highest grade is A. If he takes science, there is a 30% chance of receiving a B, 30% chance of receiving a C, and 100% chance of not receiving a D. In mathematics, he has a 70% chance of not receiving a B, 5% chance of receiving a C, and 35% chance of receiving a D. Considering only the likelihood of receiving an A or B, is mathematics a better subject choice? Option A, yes. Jim has a higher chance of receiving an A in mathematics. Option B, yes. Jim has 100% less chance of receiving a D in mathematics. Option C, no. Jim has less chance of receiving a C or D in science. Option D, no. Jim has a 30% higher chance of receiving a B in science. So here we have these options. So let's see which one is the correct option. So correct option is option C. A is incorrect because for science, we are told that Jim's chance of receiving a B is 30%, which is also the chance of receiving a C. We can work out that he must have 100% minus 30 plus 30%, which is equal 40% chance of receiving an A, as there is no chance he could receive a D. For mathematics, we know there is a 30% chance of Jim receiving a B. Adding this to the 35% chance of receiving a C and 35% chance of receiving a D is 100%. Jim must therefore have 0% chance of receiving an A. Therefore, he has a lower chance of receiving an A in mathematics. Then we have option B. It is incorrect because he has a 35% chance of receiving a D in mathematics, but a 0% chance of receiving a D in science. Option C is correct because for science, as Jim has 30% chance of receiving a C and no chance of receiving a D, he has 30% chance of receiving a C or D. For mathematics, he has a 35% plus 35% equals 70% chance of receiving a C or D. Therefore, he has less chance of receiving a C or D in science. Now we have option D, which is incorrect because he has the same chance of receiving a B in either subject. 70% chance of not receiving a B is equal to a 30% chance of receiving a B. So here we can say that we have the correct option is option C, which says that no, Jim has less chance of receiving a C or D in science. Next we have question number 23, which says if I pay £1 to throw 2 dice, I win £2 if exactly one dice shows a 5. I win £10 if exactly 2 dice show 5s. If I play 36 games, should I expect to be in profit? Option A, yes, because I can expect to win as much as I pay to play. Option B, yes, because I have the chance to win 5 times as much as it costs to play. Option C, no, because on average I will win less than I pay to play. Option D, no, because the chance of getting a 5 is only 1 in 6. Okay, so here we have a correct option is option C. And A is incorrect because it implies no loss. B is incorrect because it implies I have the chance of winning £5. Option C is correct because the net loss is £6. That is, there are 6 by 6 equals 36 different outcomes when throwing 2 dice. Double 5 should occur once, giving 10 pounds. Exactly 1 dice showing a 5 should occur 10 times, that is giving 20 pounds. Winning should be 20 pounds plus 10 pounds equals 30 pounds. The net loss should be 36 multiplied by 1 pounds minus 30 pounds, which is equal 6 pounds. D is incorrect because the chance of getting a 5 is 10 by 36 or 11 by 36, double 5 included. So that's how we can say that the correct option is option C. No, because on average I will win less than I pay to play. So this is the correct option. Next we have question number 24, which says a company did a market test of 2 products. Customers who used the products gave positive or negative comments. About 20 in 200 customers did not use product A, and 10 in 180 customers who used it gave negative comments. About 90% of the customers used product B, and 25% of them gave positive comments. Considering only the chance of product being used and liked by customers, is product A the better product to launch? Option A is that yes, product A sale will most likely be higher since it has a greater likelihood of being used and liked by customers. Option B is yes, product A's sale will most likely be higher since it has a greater likelihood of receiving positive comments from customers. Option C, no, product B's sale will most likely be higher since it has a greater chance of being used by our customers. And option D, no, product B's sale will most likely be higher since it has a greater chance of receiving positive comments from customers. So here we have these 4 options. So let's see which one is the correct one. So option B is the correct option. A is incorrect because product A has the same likelihood of being used by customers as product B. 20 in 200 customers did not use product A. So as a percentage, this is 25 by 200 multiplied by 100 equals 10%. So therefore 90% did not use product A, which is the same as product B. Here we have option B is correct because product A has a greater likelihood of receiving positive comments from customers. 10 out of 180 customers gave product A negative comments. So 170 out of 180 gave positive comments. As a percentage, this is 170 by 180 multiplied by 100 equals 94.4%, which is higher than the 25% of customers who gave product B positive comments. Option C is incorrect because product B has the same chance of being used by customers as product A. Option D is incorrect because product B has a lower chance of receiving positive comments from customers. So now we have the correct option is option B, which says that yes, product A's sale will most likely be higher since it has a greater likelihood of receiving positive comments from customers. Next we have that there is a 1 in 2 chance that field A contains oil and a 1 in 5 chance that the value of the oil found there will be at least $1,000 pounds. There is a 50% chance that field B contains oil and 2% chance that the value of the oil found there will be less than 1,000 pounds. Considering only the likelihood of finding oil and its value, and it is wiser to drill field B rather than field A. So option is A is yes, there is a 20% higher chance of finding oil valued at this value or more in field B. Option B, yes, if oil is found in field B, then there is 98% chance that its value will be at least 1,000 pounds. Option C is no. In field A, the likelihood of finding oil and it being of value greater than 1 lakh pounds are 30% higher. Option D, no. Field A has a 50% greater likelihood of having oil and the value of the oil found there will be 80% higher. Option B is the correct response. A is incorrect because field A has 20% chance of finding oil valued at its value or more. A 1 in 5 chance is equivalent to 1 by 5 multiplied by 100 equals 20%. This 20% chance is not higher than field B's chance of finding oil valued at this or more, which is calculated as 100% minus 2% equals 98%. B is correct because if oil is found in field B, there is 98% chance that the value of this oil is at least 1,000 pounds. C is incorrect because field A has a 1 in 2 chance of containing oil. As a percentage, this is 1 by 2 multiplied by 100 equals 50%, which is the same chance as field B. Also, field A has 20% chance of finding oil valued at 1,000 pounds or more, whereas field B stands for finding oil value at this, which is calculated at 100% minus 2 equals 98. Thus, the likelihood of the oil in field A being of value greater than this is lower than the likelihood in field B. D is incorrect because the likelihood of finding oil in field A is the same as likelihood in field B. And the information refers to the chance of the oil being a certain value rather than comparing the value of the potential oil in each field. So here we have again a correct option is option B. Next we have Dan and Jenny roll a fair six-sided dice. Dan will win the game if he rolls a number less than 4. Jenny will win the game if she rolls a number greater than 3. Dan and Jenny have equal chance of winning. Option A, yes, both have 50% chance of winning the game. Option C, yes, the game is fair when the same fair dice is used irrespective of the rules of the game. Option C, no, Dan has a higher chance of winning because 4 is greater than 3. Option D, no, Jenny has a higher chance of winning because she will win if she rolls bigger numbers. So here we have a correct response is option A because Dan can roll 1, 2 or 3 to win. So has a 3 by 6 or 1 by 2 chance of winning. Jenny can roll 4, 5 or 6 to win. So also has a 3 by 6 or 1 by 2 chance of winning. So as a percentage, this can be written as 50%. B is incorrect because the rules of the game can greatly affect the chance of winning. If Dan can win by only rolling a 1 and Jenny could win by rolling a 2, 3, 4, 5 or 6, Jenny would clearly have a better chance of winning even if the dice was fair. C and D are incorrect because the value of the numbers on the dice is not relevant. What is relevant is how many numbers each player can roll in order to win. So we have option A as the correct option. Next we have question number 27, which says in the country of Cambodia the population is divided into equal numbers with small feet, medium feet or large feet. Similarly, the population is divided into equal numbers with blue eyes, brown eyes or green eyes. Foot size and eye color are independent. So if 100 people from Cambodia are selected at random, then the expected number with both blue eyes and small feet is less than 35%. Option A, yes, the fraction with blue eyes is 1/3 and as foot size and eye color are uncorrelated. The number will be approximately 33. Option B, yes, the number will be approximately 11 as foot size and eye color are uncorrelated and each fraction is 1/3. Option C, no, the fraction with blue eyes is 1/3 and as foot size and eye color are uncorrelated. The number will be approximately 66. Option D, no. The number will be approximately 44 as foot size and eye color are uncorrelated and each fraction is 1/3. So here we have correct option is B. A is incorrect because the correct answer is approximately 11.33 is the number expected to have blue eyes. B is correct because 1 by 3 of people are expected to have blue eyes and 1 by 3 of people are expected to have small feet. So as the traits are independent of one another, expected number of people with both of these traits is 1 by 3 multiplied by 1 by 3 equals 1 by 9. So 1 by 9 of 100 people is 100 by 9 equals 11.1. So approximately 11 people are expected to have both blue eyes and small feet. C is incorrect because the correct answer is approximately 11.33 is the number expected to have blue eyes and 33 is the number expected to have small feet. But it does not follow that 33 plus 33 is equals to 66 is the number having both. D is incorrect because the correct answer is approximately 11.44 comes from adding 3 to 11 and is clearly wrong. So here we have option B as the correct option. Sue has 2 bags of counters. Each bag has 6 counters and each counter has a different letter on it. Bag 1 has counters labeled U, T, M, E, V and A. Bag 2 has counters labeled K, B, I, O, P and C. To win a game, a person has to randomly pick a counter with a vowel from any one bag in a single drawer. Two should put a counter with a vowel in bag 2 so that the likelihood of winning the game is the same irrespective of the bag a person selects. Option A, yes, both bags should have equal number of vowels to make the game fair. Option B, yes, the chance of drawing a novel will be 50% for each bag when a counter with a vowel is added to bag 2. Option C is no, the probability of winning will be higher if bag 1 is chosen after a vowel is added to bag 2. Option D, no, the likelihood of drawing a novel counter is the same for both bags only when they have the same total number of counters. So here we have a correct option is option A. C. A is incorrect because the number of vowel counters in the 2 bags need not be the same for the game to be fair. B is incorrect because the probability of winning will be higher if bag 1 is chosen after a vowel is added to bag 2. C is correct because if a counter with a vowel is added to bag 2, the chance of selecting a vowel from bag 1 will be 3 out of 6 and the chance of selecting a vowel from bag 2 will be 3 out of 7, which is less than 3 out of 6. D is incorrect because the total number of counters do not have to be the same to make the likelihood of drawing a vowel counter the same for both bats. So because of this we can say option C is the correct option. Then we have Kim has two coins. One coin is colored red on both sides and the other is colored blue on both sides. Dan also has two coins. Each coin is red on one side and blue on the other. Kim and Dan flip their coins. The rule of a fair game should be the person who gets a red on both coins will be the winner. Option A, yes, both Kim and Dan will have an equal chance of losing the game. Option B, yes, both Kim and Dan will have a 50% chance of winning. Option C, no, Kim will have a higher chance of winning because one of her coins will always show red. Option D, no, Kim will have a 0% chance of winning because her coins can show only one color. So here we have a correct option is D. A is incorrect because Dan will have a higher chance of winning. B is incorrect because Kim will have a 0% chance of winning. C is the same reason. D is correct because Kim's coins cannot both show red, as one will always show red and other will always show blue. So that's why we have a correct option is D. Next we have Annie and Sam have 10 white marbles, 10 blue marbles and 2 bowls each. Annie puts 1 white marble in one bowl and the remaining 9 white marbles and 10 blue marbles in the other bowl. She then draws a marble randomly from any one bowl. Sam puts 1 blue marble in one bowl and the remaining 9 blue marbles and 10 white marbles in the other bowl. He then draws 1 marble randomly from any one bowl. The person who draws a white marble wins the game. Sam has a higher chance of winning the game. Option A, yes, Sam has no chance of picking a blue marble because he is more likely to select the second bowl than the first bowl. Option B, yes, Sam has a greater number of white marbles in the second bowl, so he is more likely to draw a white marble. Option C, no, Sam and Annie have an equal chance of winning because both have 1 marble in one bowl and 19 marbles in the other bowl. Option D, no, Annie has a 100% chance of winning if she selects the bowl with 1 marble, and she will have almost a 50% chance of winning if she selects the bowl with 19 marbles. So here we have option A is incorrect because Sam is equally likely to select each ball. B is incorrect because Sam may select the first ball. Here he has a 0% chance of drawing a white marble. C is incorrect because the single marble Annie has in her bowl is white and the single marble Sam has in his bowl is blue. Therefore, they do not have an equal chance of winning. D is correct because Annie has a higher chance of winning. Sam has a 0% chance of winning if he selects the bowl with 1 marble, and he will have just over a 50% chance of winning if he selects the bowl with 19 marbles. So here we have option D as the correct option. There are only white, gold, black, and silver counters in a bag. The probability that a white counter is selected at random is 0.3. The probability that a black counter is selected at random is 0.3. The probability that a gold counter is selected at random is 0.2, greater than the probability that a silver counter is selected at random. So the question is that the probability of selecting a gold counter at random greater than the probability of selecting a white counter at random. Option A, yes, because the probability of selecting a gold counter is 0.4. Option B, yes, because the probability of selecting a white counter at random is the same as the probability of selecting a silver counter. Option C, no, because selecting a gold counter or white counter at random are equally likely events. Option D, no, because there are more white counters than gold counters in the bag. So here we have a correct response is option C. A is incorrect because the probability of selecting either a silver or gold is 0.4. B is incorrect because the probability of selecting a white counter is 0.3, while the probability of selecting a silver counter is 0.1. C is correct because the probability of selecting either a gold or a silver counter is 0.4. Since the probability of selecting a gold counter is 0.2, greater than the probability of selecting a silver counter, probability of selecting a gold counter. D is incorrect because there is the same number of white and gold counters in the bag. So we have a correct option is option C, that is no, because selecting a gold counter or a white counter at random are equally likely events. I hope you guys understand each and every point in question. If you have any confusion, you can ask me in the comment section. And if you wanted to buy any book, any best-selling book or any other daily use product, you can buy from our website, which link is given at the description box. So I'll be back with another video. Till then, just take care and goodbye.